Troubleshooting Internet Access. In this nugget, we'll be addressing Internet access for your servers. And most of the time, we don't care about servers and the Internet. But for some servers, we do really want them to be able to access the Internet in scenarios like this. My ISA or proxy server, hey, that's its whole job. It's supposed to access the Internet for my clients, so got to make sure it's on there. Also, for my VPN servers, they're going to be accepting connections through the Internet, so I need to make sure that that's configured properly. And I also need to make sure that any names that I have being resolved to my ISA server or VPN server are properly registered within DNS. Or in some cases that they're not registered. And we'll take a look at why you might not want to register them. Also, if I'm moving DNS servers around to different locations or changing their IP addresses, I need to make sure that their configuration changes either statically on my servers, or if I'm using DHCP reservations for my default gateway and for my DNS servers as well as IP address assignment, I need to make sure that those addressing schemes, those scope options, are now properly configured if I've made any changes, so that I can continue to gain access to the Internet. Also, with Internet connection sharing and NAT, we've looked at those in the past, but there are some complications with DHCP and DNS we'll look at. And then there are some browser settings you can also use, as well as IP tools, to make sure that you can gain access or check your access to the Internet. You know, when it comes to some of your servers, you might not even care if they access the Internet. I mean, for example, my sensitive file server that has confidential information on it that doesn't really need access to the Internet might not matter to me that much. In fact, I might not really want it on the Internet. How about my SQL server that's got all my confidential company data on it? How about my domain controller that has, of course, my whole database of users and computers on it? Well, I might not want to compromise some of those things by exposing them to the Internet. Fortunately, we do have some other servers that do access the Internet for us that can help to protect us, because in most networks, even those systems you don't really want to directly access the Internet, they're still going to, some reason or another. For example, they might need to download an update from the Internet or something like that. Well, a couple of kinds of servers that you'll see accessing the Internet will be something like an ISA proxy server. ISA is Microsoft's version of a proxy server. A proxy server accesses the Internet on behalf of someone else, and normally that's going to be on behalf of everybody else behind the proxy server. It also serves as a firewall. Internet security and acceleration is Microsoft's version of that ISA server. So, of course, this is one of the servers that we have to make sure that constantly has access to the Internet, because we're retrieving Internet content on behalf of our clients from behind here, from our desktops and all of our other servers that are accessing the Internet. Another server that needs Internet access would be your SUS server. We talked about that earlier in our same series here. Now, the SUS server, of course, has to access the Internet on a regular basis to download updates so that it can proliferate those updates to the other clients and servers within my organization as well. So, Internet access now is more important, I think, than it has been in some years past, at least in terms of concept, where we've thought of just users accessing the Internet to go shopping and buy plane tickets and that kind of stuff. Now, what we need to keep in mind here is how to actually troubleshoot this Internet access. And like with many things that I've mentioned previously in this series, a lot of the troubleshooting really is just preventive, making sure that you've set something up properly in the first place. Or, in this case, if some configuration changes, that you change those same configuration settings on other servers. For example, maybe I have changed the IP address to this ISA proxy server's gateway address right here. Well, the SUS server is pointing at the gateway address that it knows about because it's getting that from a reserved address maybe on a DHCP server. Well, if I change the IP address of this gateway and I don't notify the DHCP server so that it can then identify that to all of its leases so that everybody gets updates to whatever the default gateway is now, well, then they won't be able to access the Internet. They'll be going to some old gateway that just goes nowhere, that doesn't even actually exist anymore. So that's a pretty important item there. Also, let's draw another thing in here. If I had a DNS server, if I've changed the IP address for my DNS server, then if I've got that in my DHCP lease out here, my scope options for scope option 6, and that's been changing for my DHCP, or rather my DNS server, I need to make sure that that's also updated. Because otherwise, again, people that need to access the Internet, servers that need to access the Internet, are going to be accessing the wrong server, or no server at all, to access the Internet for name resolution. A lot of the other Internet-related issues in relation to getting access on the Internet come back to some things we've already talked about in previous nuggets here. For example, with DNS here. What if I have it configured to access root hints? Well, if that's the case, then when my SUS server needs to find whatever it is, update.microsoft.com, it'll go out to DNS to try to resolve that name. This DNS server is a corporate internal DNS server, so it doesn't know. So it goes out to root hints, which comes back out here to my ISP, which is going to allow me to gain access to root hints servers, and I'll have some top-level domain server or some root hints server out here on the internet, which will eventually, through recursion and so forth, get the answer for me, pass it back to this DNS server. Now I've got the answer back here on this server. However, we come into a problem with this if we have decided not to use root hints on that DNS server anymore. Maybe we restructured something. So that specific DNS server is going to be used only for internal queries. Well, we no longer have root hints. Now what happens is when this server goes out here, what's going to happen? It's not going to be able to resolve it. Typically, the chances are here that we're also going to have it so that it disables recursion if we're only going to use it internally here now. And then, therefore, we're just never going to get any answers on this sus server. So again, those DNS changes are something to keep an eye out for, and that'll especially happen at times if you're in a larger organization where you're not having probably the best communication that you can have between different departments, and whoever's in charge of DNS isn't notifying everybody else of all the changes they're making. Well, just make sure that that's all up to date, and if you have any problems with your DNS resolution, check that kind of thing out. Now remember also, I might have a reservation on my DHCP server for this sus server. Well, that works great. In reality, most servers will just have static addresses regardless. But anyway, I might have a reservation, and now then, if this DHCP server goes down, then me on this sus server here, as well as a lot of my other desktop clients, we're going to start getting 169.254.0.0 addresses. And remember what that is? That's an APIPA address that's not good on the internet, and it won't even go across a router. So that's also another thing to look for, is to see if we have clients getting any addresses in this range, and we know immediately then that we're not getting DHCP addresses. That might also happen if somebody decided to move this DHCP server to some other segment on the network, and having done that, we never configured a BootP router or a DHCP relay agent or something like that. So we got one portion of our network that's getting addresses and the other portion that's not. Again, that comes back to now my sus server and any other servers out here that have reservations from that DHCP server not being able to access the internet. Now, if I do this on a smaller scale, maybe I've got just a small office, home office out here, and instead of buying a full-blown ISA server, some other proxy solution here, I've just got ICS, or Internet Connection Sharing, over here on maybe a bare Windows 2000 server, a less expensive server of some kind. And in the background over here, we've got our network, and maybe we still are using DNS over here in DHCP. Even though it's a smaller network, we still have to have certain kinds of services, right? Well, if we've decided to go to ICS after having used DHCP and DNS on the same network, ICS is going to give out IP addresses, and it's going to give those out in the 192.168 family of IP addresses. Now that's going to cause a situation in which I have a race condition, because now I'll have two servers giving out IP addresses on the same network, and you can imagine the kind of problem that is, especially if this one's giving out 10 dot addresses of some kind or something like that. So then we're going to really run into an issue there also with DNS, because this ICS server with ICS is going to resolve names by default on behalf of the clients. The clients don't have a configured DNS server. When they request an internet name, it goes to the ICS server. The ICS server goes to whoever its DNS server is, whether it's an ISP or something like that, or whether it's another DNS server in the network, whatever. But my clients should not be pointing directly to a DNS server on their own. Now that's a little bit more obscure in the light of the fact that for larger organizations or even medium organizations, you're not going to use ICS. However, even if you decided to use NAT instead of ICS, which is a little bit more feasible for small to medium-sized organizations possibly, then remember that NAT also gives out IP addresses if you so configure it. Well, again, we don't want it to conflict in its range with whatever your DHCP server is. So, if you're going to use ICS and NAT, in most cases you're going to cut out your DHCP server and you're going to cut out DNS services as well. That might sound extreme, but remember, if you're on a small network, you probably only have a single segment here. You really don't even need DNS in that network to begin with. And then for your clients, again, you'll just point them, you'll just have them getting their IP addresses from this server over here, and this ICS or the NAT server, whichever one you decide to use, will resolve names on behalf of those clients. Now I cleaned up a little bit here to present a different scenario. Let's say that down in this branch office, I have another server down here, and this is going to be something like some kind of a virus update server. UPD for update. And what it does is it needs to connect to the internet and get downloads from its vendor for its virus updates down to this server. But we have as a company policy that everybody must go through the proxy server. All roads lead to Rome kind of an idea here. Now this proxy server is also my RAS server. So what I have in this network configuration in the main headquarters over here, as opposed to the branch down here, is I have a DNS server over here, and this is a primary DNS server. It has zone transfers that go to this secondary DNS server down in the branch office. And in the branch office here, whenever we have a need to connect to the internet, we have this update server that will go ahead and establish a VPN connection through the internet over to the RAS server. And the DNS server is also on a VPN connection over here so it can get its zone transfers. Now, what's going to happen here is this. When we try to get our updates from the internet, we're going to go to this RAS server, which is also our proxy server. We're going to get an IP address that's one of our internal addresses. So this is my internal interface to the private side of the network. So this update server is going to wind up with a 10 dot address. Let's say 10.10.10.5. So it's going to get that address. That means that when it tries to access the internet, it's going to appear to this RAS server as if it's coming from the internal network, and then the RAS server is going to forward that out through a proxy to this IP address that's good on the internet, and then it's going to get its internet content back, and then eventually get it back down through the VPN tunnel, the updates. Well, with this configuration, if I just go with default settings for these two static IP addresses on the RAS server, we're going to run into a problem, and that is that this update server is going to connect about half the time, and the other half of the time, it's not going to connect, and it's going to really drive you nuts because trying to figure out why. And when I say connect, I mean it's going to connect to the VPN fine, but it's not going to get to the internet. Sometimes it will get the internet access and download updates. Sometimes it can't. Here's what the issue is. By default, your IP addresses, whether they're static or not, will register dynamically in DNS. So this DNS server gets both of these addresses for whatever the name of this RAS server is and this ISA proxy server is. So when this update server tries to contact by name the RAS server, for example, then what's going to wind up happening is it's going to sometimes get this IP address, sometimes get this IP address, and if it gets this IP address, it will not be able to access the internet because the nature of ISA and proxy servers is that they do not service requests that come in from the internet. It's not like it'll make a request from the internet and then just kind of ricochet off this network card and then go back out to the internet. That kind of thing doesn't really happen here. We have to have a request that comes from within the internal network on a private IP address and then makes a request by name, which resolves to this private IP address, not to this public one. So the key there then, and let me just show you real quick what you'll do here, is to go into your advanced TCP IP settings and simply deselect register this connection's address in DNS. And having done that, you'll resolve that problem now, and you won't have the public IP address resolvable through DNS. So, of course, it would be this public IP address that you would no longer register in DNS. Now, you might also be thinking, hey, wait a minute. When we get an IP address like this one we got down here, normally we get that from like a DHCP server or a scope, and it already has a configured default gateway with this IP address on it. So, how in the world are we getting, how in the world is it relevant to resolve any of this by name instead and getting the DNS server confused? Well, let's say that this ISA server down here is named ISA, 1. In that case, if you're making this connection through a web browser, that can be an issue. That'll also be an issue for any clients you have out here, maybe laptop users in hotels or anything, that are using the same VPN type of connection to get through here. And this is how that would work then. If on Internet Explorer options, if I go to the Connections tab, I've got a VPN that connects to that VPN server at headquarters. If I go to the settings of this, notice that it's going to resolve a name. It's going to have to resolve ISA1. And having done that, that's when now I could get one of two answers back as the potential IP address for ISA1. And that's where we start to get into complications with that. Now here maybe I've got a server that does need regular access to the internet, and periodically an administrator will sit in front of this console and will actually access the internet from a custom vendor's website where we've got a custom software application that they've developed for us. Now because it's custom software, they will periodically come out with a patch or a hotfix that's designated just for us. However, in order for us to use their website, they request that we use cookies so that we can use the cookies to identify which company we are, because they want to be able to distinguish us from among several dozen other companies that they also have been developing applications for. So we need to use cookies is the bottom line here. Now, in my Internet Explorer settings here, if I go to Tools and then Internet Options, we'll see that if I go to the Privacy item, this has been set to high for the cookie access. Now, as with many servers, you're probably going to tighten down the security options. You might set this up to high, and so forth. However, what this is going to do then, it's going to block most cookies, and we're not going to be able to gain the access that we want to that web server. So, if you click on Edit here, you can actually enter in the specific web address where you want to be able to use cookies. Now, notice how specific this is. This is not just www.nuggetlab.com. This is http://www.custom.software.nuggetlab.com/updates. You see, you have to enter in the exact web address here. You can't just enter in, like the domain of nuggetlab.com or something like that. But once that's been added in, then I will click on Allow, and now this location here does show up just as the domain here, but it actually shows up the entire website in what I typed in there. Now it will allow me to access cookies from that specific site. Now, don't forget when you're trying to access the internet that we can use a lot of those tools that we used early on in our whole discussion here of TCP/IP. Remember, way back early in the beginning of this series. And remember, some of the tools that you can get out of the little junk drawer there, not the ones that get you in trouble, but the little tools that you can get out of the junk drawer could be very useful for tracking down all kinds of network connectivity, but also for internet stuff. For example, the ping command. If I know a website's IP address, but I don't seem to be able to open up the web page, well, I'll just ping it and see if I can get an answer back. Also, how about tools like traceroute? If I seem to be getting just really slow access to that website and it doesn't seem to be performing very well, maybe I've got a router along the way that's been flooded or having some kind of a problem. Well, I can use traceroute to check that out. Even better yet, if I got the time to run it, would be path ping. It takes quite a lot longer to run, but it gives you much more useful information about the route between two endpoints. Don't forget also about the repair command. Remember, we can find that actually in our network connections. And if I go down here, you just simply select a network connection and click on repair this connection. If it's a DHCP allocated address and configuration that it's getting, remember that will then release and renew that IP address using DHCP servers. And it also does other things like flushes the DNS cache. That's also very handy because if you're accessing web servers, maybe even within your own corporation, that are being changed regularly, maybe you're doing an IP addressing scheme, you might have cached an old IP address for a web server. Well, you need to clear that out, so you do an ipconfig /flush DNS. Again, the repair connection thing would do that for us as well. Repair would also flush out our NetBIOS name cache by doing an NBT stat and then a space dash RR, capital RR. Remember that. So basically, just don't forget a lot of those really good tools that we used really early on for not only network access, but also for internet access. In this nugget, we discussed the internet, and not the internet at large, but just servers in the internet, making sure that they can gain access in various scenarios, such as my ISA or proxy server, which of course has to be on the internet, so that it can provide access to my other clients. We also took a look at how VPN connections have a part in this, especially if they have registered DNS, or rather registered IP addresses in DNS. We want to make sure that our clients are accessing the right addresses. And we looked at how we don't want to dynamically register certain addresses at times. And then for DHCP, again, just make sure that if you've changed your DNS server's IP address, or if you've moved off to using a different default gateway than you've used in the past, then your DHCP scope options, you reconfigure that so that the proper addressing and scope options will be appearing on your clients. Then for internet connection sharing and network address translation, remember that DNS and DHCP don't mix with those, so be careful of those complications as well as various browser settings you need to take into place. And the browser settings are where you can configure your proxy server, as well as your privacy settings and how it handles cookies. And then we looked at various IP tools, which we've talked about in the past, and which still work great, even for internet connections, in addition to just general network connections. I hope this has been informative for you, and I'd like to thank you for viewing.